This is TWiT. So you're a coder, and I take it that's what you were doing at Bing, but also a YouTuber. And you did something I think that is the most cool thing ever. You taught a game to play itself.
This is straight out of War Games, by the way, which is awesome. Thank you very much for this.
Shall we play Mario Kart?
Well, actually, at first it taught itself how to play.
Okay, that's a little scary, actually.
So there's been I've done two sort of machine learning projects with neural networks for Mario, different versions of Mario. The first one is MariFlow. That was a couple of years ago.
I remember that one. So it was that you're actually running through Super Mario World.
Yeah.
And now how do you so how does that work? You just let it play and you tell it the goal? The goal is to get to the end of the level and you just say play until you figure it out?
Yeah, so this one uses an evolutionary algorithm. So it's very close to the way that basic organisms evolved. And,
I remember a screensaver, Brev Walker. Remember that? Where you'd get a box with 4 legs.
Oh, right, yes.
And it couldn't walk, and you'd say you're trying to maximize the distance. It was a screensaver, and it would get a little farther every day.
Yeah, that's about what this is like, actually.
Okay.
Yeah.
So did you have to play? Did you have to play in order for it to learn how to play?
I didn't touch the controller at all.
Wow.
All this that you're seeing on screen, this is all decisions being made just by a neural network. So it's just this program running what amounts to a mathematical model of a brain. And it's a very simple brain. You can actually see on the screen in the middle, there's these neurons. There's only like 5 of them in the version that you're seeing right now. It's this tiny brain, but it's got some sort of instincts about what to do in different situations. It can sort of see a version of the screen that's very simplified, which is what's on the left side of the screen. It can see the simplified version of the screen, makes these really decisions based on very simple computations, and decides what buttons to press every frame or every couple frames. And that's on the right side of the screen. You can see which buttons it's deciding to press.
Are they random at first?
Yeah. So the way it works is you start off with basically an empty brain. There's nothing in the brain except for maybe a couple connections, a couple neurons.
Sounds like me.
And most of the time, what that's going to do is just sit there. It's not going to do anything.
It doesn't even move at all.
It doesn't move. It doesn't know anything about the game. Doesn't know what the buttons do. It doesn't know what the screen, what's on the screen, what that means. It's never seen anything like that. It's got no information.
But you're giving it a goal, right?
Yeah. So it starts off by kind of randomly trying a few very simple brains, and occasionally the brain has this instinct to go right, press the right button. That's what you're seeing here. And so it makes some progress in the level, and at the top left of the screen, there's this fitness score. And as it goes farther right, the fitness score goes up.
It's just like Brev Walker. So how many iterations did it have to go through?
So as it gets a higher score, it sort of breeds the better neural networks together, and that's where the evolution comes in. And so then they have children. I'm not going to explain how that works. No, but they have children, and then you get another generation, and
so cool.
And so from generation to generation, you're breeding the best networks together, and you're getting better networks that way.
So each neuron is trying to achieve something, object avoidance, or it's going for a goal.
It's not a neuron. I guess, yeah, it's kind of hard to interpret, actually. Neural networks don't have this really good interpretability. It's not like with code where you can say this line of code does this.
Right.
Any given neuron can have a bunch of different functions.
Okay.
But to answer your question, this graph shows you it took 34 generations. You try a bunch of neural networks, breed them together.
That's not bad. That's
get a new generation of neural networks. But it takes quite a while to simulate, because you have to simulate each brain in the level, and so there's like 200 brains per generation, and so it took like 24 hours to get a result where it could finally beat the level.
But that's only because they can breed so fast. If it was humans, it'd be 750 years, right?
Right. Right. It would take a lot longer. Yeah. And that's the thing is evolution has had billions of years to produce these complex human brains, and whereas this brain here, I looked it up just now. A jellyfish has something like 5,600 neurons. This thing you can see has like 10 neurons, right? It's a very basic brains. So in order to get the more complicated behavior, you need a lot longer.
What technology are you using? Is this TensorFlow or something? Or
TensorFlow is great, and we're going to get to that with my next project. But this one I actually just wrote all myself in Lua.
Wow.
It was, and I used Lua because that's sort of the scripting language that you can use in emulators.
Right.
It lets you get access to the screen and the controllers.
Right.
And so I just wrote all this code myself, and it was sort of just an experiment to learn about evolutionary programming, which I've never done before this project.
What a great experiment, though.
Let me ask about your programming process here, though, because how do you get tempted to change the code to fix an error that keeps happening?
No, that's not allowed.
I know. Or do you just let it try to evolve?
Well, you can change the code, but it's very difficult to target a
You don't know what's going on in there, do you?
Right, exactly.
Yeah.
Like if it's, getting stuck in one place, it's a little bit hard to say what changes you can make to the whole evolutionary process as a whole in order to actually let it learn how to get past that point. You don't want to just like go in and edit one connection because honestly, I don't know what connections I would have to edit to make
right.
To make
it will change all the other connections.
It's a black box.
Well.
Yeah, exactly. Yeah. It's a black box. That's exactly right. So, but there are some general principles you can use to say, and there's a lot of study about this sort of thing too. And this implementation was based on a paper by Kenneth Stanley. And so a lot of it was just kind of implementing what he did in the context of Super Mario World, and just tuning all the parameters, all the little tweaks you can make. There's a bunch of numbers you can change how the evolution proceeds, and how many neurons things get, and how many species you have, that sort of stuff. And so most of it was just based on existing research, and there's a lot of research in the area that can really help out.
Let me ask this. Will it keep its knowledge into the next level, or are all these neurons forming for this particular level and it has to repeat the process every time it receives a new field?
Yeah, for Mario, I trained the neurons on a single level, and so it only learns how to beat that one level. Now, the thing is, I actually did try to you take a brain that's sort of evolved to beat a certain level, and you try it on another level, and it usually won't beat that level. But I actually have seen it in the case of simple levels. I actually have seen it beat another level with a brain that wasn't trained for that level. So it does learn things that are sort of more general than what it was trained to learn. And that's sort of the power of neural networks, is it's called generalization. They can generalize to a bunch of different situations that they've never seen before.
So it can learn pattern recognition. It's not just rote.
Exactly right. Yeah.
Well, and this is how Google beat the world champion at Go, basically. The AlphaGo was taught to play Go not by humans. That's how Deep Blue worked. Humans taught it to play chess. AlphaGo just played a lot of games of Go.
Actually, AlphaGo did have some human input. It studied professional games, and that was sort of the starting place for its learning.
Okay.
And then from there, it played a lot of games against itself. Now, Google does have a new project called AlphaGo Zero, which does not learn at all from humans, and that project is actually done better. It actually crushes the original version of AlphaGo.
Humans screw it all up. Yeah.
Humans do screw it all up. Yeah. It's able to learn novel strategies, things humans would never really think of.
So this is an interesting part of artificial intelligence, where we try to model artificial intelligence and learning. We try to guess how a human learns and try to apply it to computer programming. Does that it seems like this works, but does it seem like the best way to go about solving these problems?
Well, people used to think that you could, if you had enough rules, you had enough facts in a machine, that it could do what humans do. It could make judgments like humans make. And really, in the past few years, we've really seen that that's not true.
Right.
The best way to do it is to have a computer learn from examples, or learn from its own exploration in much the same way that a human would learn. And I mean, if humans did it that way, then that's probably the best way for computers. But I think we've gotten some extremely good results where computers are starting to do better than humans at tasks that we never thought that computers would be able to do at all. Things like computer vision and playing games. Speech synthesis is now done with neural networks. It's generating voices, and there's all kinds of tasks where neural networks are doing better than humans.
So you've moved on from Mar.io to MariFlow.
Yeah.
Tell us about the new project.
So MariFlow is a totally different kind of learning. it doesn't try and learn on its own. In fact, it can't learn on its own because its entire goal is to try and predict what a human would act like in any given situation, and do that, act like that. And so
that sounds almost impossible.
Yeah, exactly.
So actually, if you can scroll to the beginning of this video, I have an example where 3 of the screens are MariFlow, and 1 of the screens is my dad. And so you viewers at home, and maybe you guys, can try and guess which one you think is my dad and which one is the neural network.
I think the upper right is your dad.
You think upper right is my dad?
Because he keeps jumping, he keeps hopping.
Yeah.
Yeah? Okay. Well, you'd be wrong.
Because number 3 is not your dad. It's stupid.
Wow, my dad's going to be...
Oh, Leo! He keeps driving. Actually, no computer would drive into the wall like that. That's a dead giveaway, right? That's the human going, I can't figure this out.
Oh,
so the goal is for it to play like a human. I think my
You
my
fooled
dad's,
me.
He's still learning. You
fooled me.
Yeah.
Yeah. Wow, that's fascinating. Are you're not using the same techniques for this then?
It's a totally different approach. That's right. So you can imagine, say I showed you a video feed. In fact, you can look at what's going on here. Say I showed you a video feed and asked you, and it just froze it, paused it, and said, what do you think the human is going to press on the next frame? What do you think which controller buttons do you think the human's going to press? Here, if you're looking at this freeze frame, you might think, well, they're not going to press left or right, just straightforward, because that's where the road goes. And so the neural network looks at a sequence of frames and then tries to predict what the human's going to press in the next frame. And then it gets that frame and it tries to predict what the human will do in the next frame after that. And so it's always predicting what the human's going to do.
And it could do that pretty well.
It could do it pretty well, yeah. And then when it wants to play on its own, what you do is you take the human out of the loop. You have it predict what the first frame of the controller inputs are.
Wow.
What would the human do at the very beginning? And then you feed that back into itself and say, well, now what do you think the human would do?
See, I've still got a little bit of disconnect because obviously it's not just a decision tree. This is far more complicated than a decision tree. But what is it exactly? What is it learning? So I know it's cueing on the artifacts it sees on the screen.
Yeah.
But when you say it's learning from the human, what is it learning?
On screen, you can see a picture of the inputs. That's the very top, and then it. You don't need to pause. It'll keep going. And from that, it sort of gets a bunch of neurons. It has a bunch of neurons, which it decides what each neuron sort of thinks at that moment. And then it goes on. There's actually a bunch of layers, and so it goes through a bunch of layers of these simple math problems, and it outputs a controller, a set of controller inputs. And so it's predicting controller inputs by this. And they're very simple mathematical rules, but there's a lot of math going on. There's tens of thousands of mathematical operations going on that takes the input screen and outputs some controller presses. And then once it makes those predictions, it trains against a bunch of data that I've recorded. So I've recorded the screen and I've recorded what my button presses are. And so it can take the screen, make predictions about what buttons it thinks I'm going to press, and then compare that to what buttons I actually did press. And when it makes an error in the prediction, then it sort of makes these small tweaks to that mathematical process that gave rise to the predictions. Right. And those small tweaks make it more likely to make correct predictions.
So each successive generation will be more correct.
That's right. Yeah, it'll lower the error rate in making those predictions. Wow. And over time, if you give it enough training data, it'll be able to do that in a wide variety of situations, and it'll have really low error in making those predictions.
This is
a lot to take in.
Yeah, but it's so interesting and so cool. And one of the things, so evolution happened because there was billions of years.
External pressures,
and it could just go on and on. There was an immense amount of time. Computers can do this because they can do this so fast.
They can just reiterate over and over.
And they can iterate so fast that you're thinking in a tiny, tiny chunk, but if it does it many, many, many times, it can actually simulate learning. Or is it really learning?
It is learning. It is learning. It's it is different from the way humans learn, though. There's no metaphor for evolution with MariFlow or with this type of recurrent neural network gradient descent is what they call it, learning. This is a mathematical optimization problem. It's like you take this really high dimensional curve, which represents error, and you try and find the lowest point on this curve. And so if you can minimize the error in this curve, then you can minimize the errors that it'll make in predictions. And so it's a very different form of learning from what humans do. It has some of the same results, though. But it does definitely behave differently from the way a human learns.
But you learned, didn't you?
I learned a lot from this project.
Yeah.
I've learned a lot from all these projects. I've got a lot more learning I want to do too. I'm not done with all this.
Well, tell us about that. What's next? So you've got this. You've got MariFlow. What's next on your neural learning horizons?
Okay, so Mario learns. It was a type of reinforcement learning. It learns just from its own gameplay how to improve its performance, right? And that's called reinforcement learning. But it did it by evolutionary algorithms. It learned through genetic breeding and evaluating rewards over time. What I want to do next is something more similar to what Google has done with AlphaGo, or what DeepMind's done with some of their Atari learning, where they've learned how to play Atari games really well. It's called Q learning, and I'm actually working on this project right now. I'm starting to get pretty good results. In fact, I just bought a new computer with a 1080 Ti just so that I could train my neural network faster, and it's going like 2 or 3 times as fast, which is pretty cool.
So you use the GPU to do this?
Yeah. GPUs are extremely important for neural network training. They can do a lot of operations in parallel, which is exactly what a neural network and a real human brain do. So GPUs are great. There's this new thing that Google is starting to build called TPUs. It's called a tensor processing unit. It's even better at doing these massively parallel computations.
And they're online.
Yeah, but they don't sell those, so you can't buy those.
Yeah.
Maybe we need to get NVIDIA to give you some time on their huge GPU clusters. Just to see
they
what
have GPU clusters.
Oh my goodness, they're incredible.
Oh, that's cool.
Yeah. So my new project is using this new deep Q learning. It's not a new technique, but in the past few years, it's shown some really good results, and people have started to figure out how to really apply it. So again, I'm applying it to Mario Kart. And I'm having it learn on its own. It's getting to a pretty good place. I'll probably be making a video about that fairly soon. But after just overnight training, not even 24 hours, just like 8 hours, because I have the 1080 Ti, it'll actually be able to win some races. And it finishes most of the races, which is not something you can always say about something that's learning on its own. But
so, are you working in AI now? Have you turned this into your career, or is this still just kind of a personal project?
What is the career of a YouTuber?
Oh, interesting. So are you going to make YouTube a full-time job?
YouTube's been my full-time job for the past 5.5 years. Ever since I was working at Microsoft, I quit to do YouTube full-time. Originally, I was making more or less just Minecraft videos, but they were very technical Minecraft videos. But I've sort of branched out into speedrunning, various other very technical endeavors. I love taking video games and seeing just how you can approach them from a very technical standpoint.
Look at these Minecrafts. Oh my God, this is amazing. So
what you're seeing on screen, this is an Atari emulator that I wrote in Minecraft.
Yeah, I figured that out right away. Wow. Look at that. He's emulating an Atari in here, folks.
It's slow though, because you're building an emulator inside of a game that's built in Java, that's running on a virtual machine, running on Windows. It renders at 1 frame every 4 minutes.
Look, I played this. You could play Donkey Kong. Cool. I have played this. I was so impressed. 1.9 million subscribers. I guess you could make a living.
Yeah, probably. Yeah,
that's pretty good. That's really nice.
This is incredible work. Thank you very much, Seth.
We're thrilled to meet you. And anything you want to talk about, anytime you want to talk about your next project, let us know.
Sounds great.
I think this is so much fun. You said you're going to use TensorFlow next time.
Actually, MariFlow, it's named after
TensorFlow. It's TensorFlow. Oh, cool.
MariFlow uses TensorFlow. My new project, which I'm going to call MariQ, because it uses Q learning, and also because IQ, Anyway, that also uses TensorFlow. TensorFlow has really... TensorFlow and a few other machine learning libraries have really enabled sort of the amateur enthusiasts to really get in on machine learning, and it's made it a lot easier. So TensorFlow is great. PyTorch, there's a few others out there, but it's making it pretty easy for just amateurs to get in on it. with if they do a bit of reading and understanding about how this stuff works.
Use OBS for doing your videos?
I use XSplit for streaming, and usually for making the videos. Although I also do use like DxTory to record. I'm
asking for a friend. So it looks like your most viewed video, 1.8 million views, is SNES code injection.
That's not my most viewed video.
What's your most viewed video?
My most viewed video is a Minecraft animation. It's called Bite-Sized Minecraft.
Wow.
It's sort of more of a set of comedy sketches. But that one's not as interesting to the to the geeky.
I was encouraged that a video on code injection got almost 2 million views. I thought that's a really good sign. YouTube's not just for crotch shots anymore.
12 million. His most has
12 million. When you say the word Minecraft, you get automatically 6 million.
It helps. Yeah. I mean, Super Mario World's like a 20-something-year-old game at this point. 25, 27. So I've done a bunch of work with Super Mario World. I've actually learned how to program for Super Nintendos so I could do all this work.
Wow.
And
so you actually made Flappy Bird in Super Mario World.
That's right. Yeah, and in fact, that's
it's like a turducken of video games.
There's a turchick-duckin. Like there's even deeper. So I've actually done a jailbreak for Super Mario World. So the jailbreak, it permanently sits on the cartridge. There's a bit of RAM. There's 2 kilobytes of RAM in the Super Mario World cartridge. It's battery backed, so that's what stores the save files. But if you put the right data there, when you try and load up a save file, it'll trigger whatever code that you want that's stored in that battery-backed RAM. And so you can have this persistent hack stored in the cartridge. It's a jailbreak. What I've written is a jailbreak that includes a hex editor where you can view and edit any memory on the console while you're playing the game. And so you can like change your power up, give yourself a cape or even invalid power up states. But it also includes a mod loader. So you can write in bytecode, in hex, you can write in a mod and load in a mod for your Super Mario World on a real cartridge with a normal real Super Nintendo. There's no like modified hardware. It's just bits being stored in the cartridge.
This might be too much
to ask, but can you do this on the SNES Classic?
I haven't tried yet. I did do it on the Wii U Virtual Console. And I assume that
I guess if they're going to emulate it, they got to emulate it, right?
Go.
I think the virtual or the SNES Classic is a very related emulator. So that's actually one of the things that I plan on doing very soon is installing this jailbreak on a SNES Classic.
Wow.
Yeah, there's a mod that you can see written by P4+2.
Look at that.
Where you can, it's a telekinesis mod. You can move enemies around and.
Is it 6502 assembler? What is the chip in there?
6502 is the NES. The 65816 is the SNES.
And you have to write it in 65816, right?
That's right. All the bytecode you see on there.
And you're not typing in hex codes for your assembly language.
He sees the matrix.
I assemble it on the computer and then I get a bunch of bytecode, which I can enter via the hex editor on the jailbreak on the Super Nintendo.
And I thought it was hard typing in basic games from Compute Magazine. What do I know? Hey, I am really impressed, Seth. What fun. SethBling, the youtube.com/SethBling. Subscribe, follow him. He's up to some no good that is really good. Really
we like the no good.
Thank you, Seth. Great to talk to you. Wow, is that fun, huh?